welcome for this session. I hope you're enjoying the conference as much as I'm doing. So this is the last slot of the day, and I'm going to speak a bit about EcoreTools 2.0. My name is Cedric Brun. I'm one of the many committers in Eclipse, doing lots of stuff, and I'm involved in several modeling projects, and one of them being EcoreTools. And I'm also the CTO of OBO, a French company dedicated to model-driven solutions and products. So, how many of you already used EcoreTools? Okay. So, this is EcoreTools 1.0. It's been done like maybe 4 years ago, something like that, by the original team, which was from Anywhere. And when they created EcoreTools, they wanted to use GMF tooling at its full potential, like using GMF tooling in the best way possible and separating the generated code, the non-generated code, and so on. Unfortunately, the company got acquired by another company at some point, and then the team had to switch focus. And EcoreTools became quite dormant, to be fair, to be nice even. So the problem is EcoreTools is one of the first thing people are trying and using when they want to adopt Eclipse modeling technologies. So you have to do an Ecore file, and most of the people want to be able to create this Ecore file using a diagram editor. I mean, that's a class diagram, everybody knows that. So, as this was a big problem for the Eclipse modeling ecosystem, then Ed Merckx and I stepped up so that at least we would have builds of EcoreTools. So for a few years, we made sure that EcoreTools was still in the release train because so many people were using it. And we were trying to find a new team to do new developments and new features in EcoreTools, but we kind of failed for this. We had discussions, but nothing more than discussions. So this was the state of EcoreTools like a few weeks ago. But in the meantime, OBO and Thales decided to contribute the Sirius technology into Eclipse. And why is that changing anything for EcoreTools? But, well, mostly because then building a graphical modeler is as easy that even a single person can do it. So I was using my time on EcoreTools to maintain the builds, make sure it works, fix the most prominent things, and using Sirius and using in EcoreTools based on Sirius, and I'm able to push new features, and that's what I'm going to show you today. So this is the EcoreTools 2.0 version, the latest build. So graphically, there's not many differences compared to the previous one, but there's lots of other features which I added. And the Sirius runtime itself provides its own bunch of features. So I was in the situation of, okay, so what should I do? I mean, is that just a class diagram? Everybody knows what you want to feature for a class diagram, except while having these boxes and edges. And so I started by thinking about, okay, I'm going to work on EcoreTools and push new features, but what features should I do? And one way to do that is to think about user experience. And one way to think about user experience is just to figure out some user. So I started by building personas. One persona is, for instance, Bob. Bob is a student which is a computer science student in a university. And Bob is being asked at some point by his teachers to work with EMF to do some kind of project. Bob is an interesting persona because Bob doesn't know anything about Eclipse. So how Bob can figure out how to use EcoreTools, which is the first step he needs to go through to be able to use EMF. But I'm not going to speak about Bob. I'm going to speak about Alice because Alice is way more interesting. So Alice is 30 years old. She's been doing EMF and Eclipse modeling technologies for at least 5 or 6 years. She's very good. She's an independent contractor. So what she does basically is she comes to customers to help them adapt Eclipse modeling technologies, either to build tools or to build business applications. So I really like Alice because, of course, it's easier for me to get into the shoes of Alice than Bob, because Alice knows everything about Eclipse. And Alice is more a power user than Bob. But I'm thinking about Bob too. But you'll see maybe in a future blog post or something. So once I define Alice, then what does Alice do? Well, she needs a tool to prototype domain models with the customers. And she used EcoreTools because it's easy to discuss with the customer with a class diagram. But then she really needs focus diagram, not like seeing all the Ecore model of the customer. She needs to use the diagram as a means to communicate. On the other hand, she's also prototyping with the customer next to the customer. So we really want her to be efficient with the tool. We don't want Alice to look bad in front of the customer, right? She's an independent contractor, so she won't get any more job if she looks bad using EcoreTools. And as she's discussing with the customer, she needs to take note, she needs to document things, and then she come back home, and then she needs to review what she did. And so starting from this, I started to create features which support these kind of use cases. So I'm going to start with a demo of the current state of EcoreTools. I'm not going to show everything because I won't have enough time. And then I will move on how I built these features using Sirius. So Alice as a customer, she's working for the Eclipse Foundation right now because they're doing so many conferences that Anne Jaco is having a hard time figuring out how to organize the conference and stuff like that. So she wanted a tool to do that. So Alice is next to Anne, and she's working with her to capture the domain model of managing conference in Eclipse. So she starts by creating a project, which will be the conference model. So here we have a modeling project at the left. So here we have the Ecore model. This file contains all the diagram and representations. Here we have one of the diagrams, which got initialized. And right now, Alice is in a design phase. So we have what we call the viewpoints in Sirius. You can think of the viewpoints a bit like perspective. So we basically have several viewpoints with EcoreTools now. So we have the design viewpoint, we have a generation viewpoint, and the review viewpoint. I'm going to show 2 of them. Each viewpoint provides its own set of editors, and each viewpoint can customize other editors. So if Alice is doing some design, she uses the design viewpoint. If she wants to review things in her model, she can activate the review viewpoint, and so on. But here we're in the design phase, so Alice is just going to create the model with Anne. So she starts by creating a few E-classes, and well, okay, we have a conference. Of course, we have speaker, we have sessions, and we probably have slots. We'll stop here for now. So I really wanted to make sure that everything can be done quite quickly. She will of course start by creating composition. So our conference, we'll have sessions, we'll have speakers and slots. And see, we have an instant feedback on whether something is wrong or not. So here, the conference E-class is not valid from an EMF point of view because it has several references which have the same name. So I can consult the message through the tooltip. So we have slots and speakers. And of course, she can create references like slot, well, now I'll say a session as at least one author. So, and then we have this cardinality thing to think about, right? So at least means at least one. But if I really want Alice to be able to work pretty much in this mode, like in full screen mode. She's with Anne, she don't want to mess up with the Eclipse views. It can get pretty messy. So the idea is being a bit smarter when she can edit the label. Right now, if she says, okay, it's a 1 here, 1 means it's mandatory. And so the reference gets the lower bound to 1. But we can have several others, so I just type star, and then we have, well, the upper bound, which goes up. Of course, there's also support for E opposites. So E opposites are represented, I would say, traditionally like roles in UML diagrams. So this is an E opposite relationship. And as we're in full screen mode, sometimes she needs other properties. And so I use the EF project so that if she double clicks here, then she has some kind of wizard and she can change stuff and say, okay, session renamed and finished, and well, it updates the model. Same kind of shortcuts is maybe session should not be an E-class, but an abstract one. So I could have created the abstract class like this, but I already created session. So I can just use the same tool, which is abstract class, but clicking here, and it's fine. It's changing it into an abstract class. Or I could have used the shortcut here and said, okay, that's an abstract class or an interface, so on. I'll create just a new operation, which doesn't have many sense. Let's say the conference start at some point, and well, and when it starts, we have a message. And here, just typing the signature, the model gets updated correctly, meaning there is an E parameter, which is here, which has the right type. For E attributes, it's pretty much the same thing. I can pick, okay, the title of the conference. Here it's not valid, I don't have any E type, but I can say, okay, the title is an E string. But then I could say, well, I want to rename my title attribute, like in name. If I just type the name, then by default the tool is just going to change the name. You don't have to type the type itself each time, because that's painful, right? So she's still with Anne, and now she wants to focus on what kind of sessions she has, and she wants to create a diagram for this. So she creates another diagram, which of course is on top of the same model. And the other diagram is kept in this file. But the diagram is empty because by default the diagrams are empty. I did not want EcoreTools to display everything in the model at first, because then if you have a big Ecore model, it's painful. But you can import stuff either by drag and drop or by picking it here. Okay. So now I have my sessions, and I would say, okay, we have 3 kind of sessions. We have talk, we have keynote, and we have maybe both. Okay, but then, you know, Alice, she likes Eclipse, but she never went to EclipseCon. So Anne explains her stuff, and she really needs to capture this. And we have another layer here. So here are the layers on the diagram. We have one which displays validation. For instance, here, this is invalid, but the layer is disabled, so nothing is red. But if I enable the layer, then this comes to be red. And I have another one for documentation. And in the documentation layer, everything which is not documented is red. But then Alice can, when I enable the documentation layer, I have new tools appearing here, which are focused on documentation. And I can create an annotation. So here I can create an annotation like both. Both means birds of feather or something like that. Of course, everything is synchronized in the sense that here in the property views, I can see the same documentation and I can fix stuff and it gets updated here. Okay, I think I'm pretty much done with this part of the demo. So that's the kind of stuff Alice does with Anne. And then she comes back home and says, okay, now I really need to think about what is the model exactly, thinking about dependencies versus other e-packages or thinking about abstractness and stuff like that. And she will probably use another viewpoint which is, contains other editors, which is a review viewpoints. And once the review viewpoints is enabled, then she can create other representation. One of those being the documentation table. And the documentation table is just a convenient way of setting all the documentation in the Ecore model. Here again, of course, everything is synchronized, meaning that if I change, like, if I add a documentation here, keynotes are great, then it appears here. And the choice that this appears automatically has been done by me, the designer of EcoreTools. That's something which is configurable. The E-class, for instance, is not appearing automatically. This one, this node is. She also works with customers which are doing their own Ecore. And most of the time, their own Ecore are quite big. So she often have to explore an existing Ecore. So I'll take an Ecore which looks quite a lot like many customers' Ecore, which is a UML one. So she can open it. Here again, she has the different kind of viewpoint she can use. I use the design one. And I just use this Ecore just to show you that you can also explore an existing Ecore with this tool. So you can start with something like a class. So this is a class in UML. Let's make it auto-sized. And from the class, I can explore the related elements. So these are the elements which are related to the class, E-class, in some way. So like, for instance, behavior classifier. And then I can start building my diagram. And I can start building my diagram in a way that it's meaningful, right? So I'm trying to explore stuff and put stuff which are interesting with this use case, for instance. Again, I can enable the documentation layer and just see that UML2.ecore is very well documented. So okay, that's pretty much it for the demo. There's other views. I'd like to show it to you if you want, and join me later. I go back to the slides. So this is the life of Alice, and what we've seen, what I'd like you to remember from this demo is that the diagram has semi-synchronized, meaning some stuff are appearing because the end user asks for it. Some other stuff are appearing automatically based on the content, the existing content of the diagram. So we have layers for documentation validation, and we can import elements one by one. The graphical style is slightly redesigned. And I try to add as much shortcuts, editing shortcuts as I can think of, like the smarter edit, a documentation table, and many more, because some of the features are coming from Sirius, like, for instance, the ability to pin elements on the diagram so that an automatic layout will not lose their position, stuff like that. So now how it's done. So this is the stack of EcoreTools globally. We have EcoreTools 1 here, and EcoreTools 1 is relying on the GMF runtime and on EMF and all that stuff, and GEF, of course. And EcoreTools 2 is actually not very far. It's just relying on the Sirius runtime, which itself relies on the GMF runtime, and so on. So it just went above an additional layer. And how does Sirius work? Well, you have Ecore models, so your domain models, like, for instance, Ecore.Ecore or UML.Ecore. And then you can define the viewpoints I just showed to you. So you define the viewpoint specification model, which is going to describe how your tool should behave. This is split on viewpoint, and then each viewpoint can have several kind of editors, diagram, table, trees, and that's extensible. You could plug your own type of editor. And from this, which is a viewpoint specification model and the Ecore, this is your tooling. And then if you ship it to the user, they can use it through the modeling project with their own instances, creating several instances of diagram, for instance, which are instances of this diagram definition displaying this model and so on. So that's the general behavior of Sirius. And for instance, in Ecotools, we have, so this is the project here, and this is the viewpoint specification. So here you have all the behavior and all the features of the diagram I just showed to you. Let's dig a bit deeper into this diagram definition. This is mixing several kinds of information. The first one being what we call the style, which is actually the graphical shape of what you want to display. So this information is kept in this model, like, for instance, in EcoreTools, we're displaying e-classes with a flat container, with rounded corners, and with some specific colors. And we can say things like, okay, if this is an interface, if the interface attribute is set to true, then the style is slightly different. And so this information is mixed with other information into this viewpoint specification model. So we provide, through Sirius provides a bunch of styles by default. Of course, that's extensible, and you can always add your own images if you wish. And these are the styles which we're using in EcoreTools 2.0. Well, basically mostly container of kind, list containers. And I used quite a lot the colors. For instance, everything which is derived is in blue, and everything which is mandatory is in bold. So with this kind of rule, then somebody who knows the tool and have an Ecore model can easily analyze it and see if this should be mandatory or not. All the behavior of the tool is also specified in this model. So everything which is in the palette here is specified here with tools which have some specific behavior. But not only, anything you can do in the modeler, like drag and dropping, reconnecting edges, all that stuff can be defined in the model directly and are going to be triggered when the end user interact with the tool. And the last but not least, the mapping definition. So we have mappings in this model which basically are saying what kind of semantic elements should be mapped to what kind of styles. I go back to the mapping. So here we have a semantic model, which is an Ecore model, which is represented as a graph. And this semantic model is going to be browsed by Sirius to determine what kind of shapes it should display. So let's say we have a mapping for the classifiers or for the E-class. The mapping is defined with two main things. The first one being the type. So the mapping is bound to a given type, which is here eClassifier, and what we call the semantic candidate expression. The semantic candidate expression is a query which can be OCL or Axilio or even pure Java code. And the query responsibility is to retrieve from the starting point, which is here, retrieve all the instances which should be displayed, which could be displayed. That's why it's called candidate. And so from this, then as we bound this mapping with a shape, then the corresponding shapes are here. But Sirius will not necessarily create them automatically. That's part of the thing you can set up in the mapping. You basically have two synchronization policies. Either Sirius will automatically create those, or Sirius will not create those, and then you have to provide some other tool, like drag and dropping, to create the views. In the case of Ecotools, we have the mapping for a class, which is basically just that. Like, we have an ID, we have a mapping to the e-class domain class. We say it's a list, and we say it's not synchronized, meaning e-classes will not appear automatically in your diagram. If you add a new e-class in the e-package, it's not going to appear in the diagram. You need some other tool to make it appear. And here you might notice that the semantic candidate expression is empty. So that's a shortcut in Sirius to say any e-class. Any e-class in the given resource set can be displayed with this mapping. E-references, on the other hand, I want the e-references to get created automatically. If I have two e-classes and they have an e-reference between them, then I want the edge to appear. So e-references are bound to the type e-reference. And these ones are synchronized, meaning they will get displayed automatically. The semantic candidate expression here is a bit more clever. I could have said, okay, all the references of the resource set. But if I do that, then potentially Sirius has to browse all the resource set. And I know that I only want the references which are displayed in the diagram, which are linked to an e-class which is displayed in the diagram. So I just say, okay, I'll take the displayed e-class in the diagram and just take these references and flatten this list. So that's some OCL with a few calls to Java in the same time. So tooling is specified in a model and interpreted at runtime. The coupling between the semantic model and your graphical model is very low because it's based on queries. The synchronization policy can be specified on a pair mapping basis, and you can use query in OCL or Axelio or whatever. The problem, well, not the problem, but the drawback with that is because of these queries, we can't really infer the tool part, you know, the palette part at the right. We don't know what the hell you might want to do if somebody click on e-class and click on the back of the diagram, because we might be displaying something completely different. That means you have to specify it. But we've seen by experience that most of the time you want to specify it anyway. So the tools are specified with a small, very small action language, which have a few operations like creating an instance, updating value, removing something, deleting something, iterating, and creating a view, and so on. So for each tool, you can define what happens into the semantic model. And then Sirius will refresh the diagram and the representation. And these tools are used to create elements, of course, but also to reconnect, to drag and drop, direct edit, and even some specific pop-up actions that you could define, like the one in EcoreTools to retrieve linked elements. And so it's all defined in the model. But sometimes things are quite hard to express in this action language. For instance, the label edition I just showed you, like the guy typed just something, then I changed the name of the feature. The guy typed some type, then I only change the type, just one, and I change the cardinality and so on. So this is very easy to write in Java and very complex to write with this small action language. So you can easily call a Java method like this. The Java method is given the current e-reference and the current string, and just, well, do some bit of parsing and set the stuff. I just have to import the Java qualified name, and then I can call it within any Axilio expression or call it directly, for instance. So in diagram, you can create layers, and for instance, the documentation layer, and a layer can do three things. It can add new mappings, which are going to be displayed. It can add new tools, which are going to be enabled in the palette, for instance, or it can customize style. For instance, the documentation layer makes the border go red if there is no documentation, but if you disable the layer, then this effect disappears. So because of this low coupling with the semantic model, we don't care about the containment, for instance. On the other hand, you have to define what happens when the user interacts. There is a simple action language for this, and you can call Java. That's always an option. And the expressiveness is pretty rich. Diagrams have layers, filters, tools, decorators, and lots of other stuff like that. I'll finish with my own persona. So I'm Cedric, and I'm the guy which is creating Ecotools now. So I care about a few stuff, like consistency, performance, building, testing, and stuff like that. So just a few things, but when I speak about consistency, I speak about the consistency of my diagram editor. For instance, I use gradients, and that looks very bad if in some diagram I use a gradient which has a given orientation, and in another diagram the orientation is different. And this can easily happen if I don't pay attention, right? The good news is, as you just have a model and your specification and your tooling is a model, then you can easily check this kind of consistency. It's a bit like if you had your own check style that you can easily write in a unit test. So I've wrote down unit tests which are checking stuff like, is there any reconnect tool for this edge mapping? Because I want the user to be able to reconnect everything. If there is not, then the test is failing. That's the small things. But another thing which matters a lot is performances. So Sirius provides a profiling mode. You can enable it in the preference page. And when you enable the profiling mode, then you just use your modeler, and you can go opening the time profiler view, and you'll see all the time which is spent in doing stuff and in each query. Because most of the time, if you have poor performance, it will be because you've wrote down a poor query. So doing that, you can easily, with a given instance, see what takes time and fix it. And in the end, this is just an Eclipse plugin. It's an Eclipse plugin with a bit of Java code and with a model description, which is important for me because I don't want to spend too much time building it or distributing it. I don't want other stuff than the stuff I'm used to do when building Eclipse plugin. So I can set up a Tycho build. It's just a classic Tycho build. There's nothing weird. I can create JUnit test or SWT-bot test, and I'm done. So as a maintainer of Ecotools, that matters to me. And for information, the Ecotools 2.0 is 18 Java files. That's all. 2,000 lines of code. All the rest is in the model. So all the rest I can manipulate it programmatically or using tools. So models at runtimes means something easier. But you have to care about performance to have a good one. There's no magic bullet here, but Sirius helps you to measure your performances. And modeling workbenches are just Eclipse plugin, which you can ship, just distribute like other Eclipse plugin. So I'll finish with a small roadmap. Actually, the first commit of Ecotools 2 was like maybe 3 or 4 weeks ago. So that's pretty new. But now that Sirius is into Luna, I could add Ecotools 2 into Luna. And so now it's built and aggregated for Luna M3. It's not really, well, some features are not installed when you install it from Luna right now, especially the properties. I expect this to be fine, so installable and usable in general for M4. And M5 will bring better property views, other stuff. I have a few ideas to add as a feature. And I'd really like to hear from you if you have stuff which are bothering you with the current Ecotools, and if you find a way to overcome them. And in the end, for Luna, I'm going to ship the Sirius-based modeler and the GMF-based modeler at the same time, so that people who want to keep the old one for one more year, they can, and they wait for the more perfect version of EcoreTools 2, because others will have tested it for them. So I'm pretty much done. I know that was quite packed with lots of things, so I hope it was not too much. If you want to learn more about Sirius, you can come to the booth at 7, I think. We are also at the booth, and I'm really looking forward to have your ideas of things I could add which would help the user experience, for instance, or which would make Ecotools more cool, because as I said before, now that it moved to Sirius, it's quite easy for me to add features like that and to maintain it at the same time. So thank you for your attention. And do anybody have any question? Yep.
What about migrating from the old Ecore diagrams to those?
So migrating is technically doable, really, because in the end, Sirius has a GMF notational model and Ecotools 2, so the coordinates are pretty much mappable. I have no plan to implement this right now. Well, not that, as I said, it's doable, but it's not very fun. So anybody who wants to do that, I'd be very willing to help him. But I try to, recreate another diagram from an old diagram. And as you can install both at the same time, it's actually pretty easy to do it by hand. And while the Sirius versions is easier to lay out because the router are more capable. So that would probably give a less than perfect result by migrating, because then I would have to set the breakpoints explicitly. And well, anyway, if anybody is interested, I'm willing to help, but I don't plan to do that, except if I did all the cool stuff I have in mind in the meantime. But well, we'll see. Yep. So I did not try lately. I tried with Ed at the latest EclipseCon, and it was working. Meaning, what was working was the ability to see the diagram, the Ecore diagram, on top of an Xcore model, because there is an Ecore model inside. So it's actually working quite well. On the other hand, if you edit the Ecore, then Xcore is not able to update itself. So then you end up having some kind of exceptions. An alternative would be to have to edit directly the Xcore model. So that sounds doable too, and probably not a lot of work. When I looked at it, it looked like the Xcore model had not real references on the elements. So I figured maybe I have to find the value of this reference in some other way. Well, anyway, no plan for it, but I'd like to try it and maybe discuss with you guys and see what's possible. Yes, Ed?
I was going to ask about Xcore, but also about GenModel and CLV for the applications. Is that extensions that are possible?
Sorry?
Supporting GenModel, maybe that's what you had in your generation view.
Yeah.
But presumably one could also add a customized de-annotation.
Yeah.
Embedded in.
That's definitely doable. Probably like a couple of minutes of work. So why not? Thank you again. don't forget to evaluate the session. The program committee needs this for every EclipseCon, and I need this so that I can get better. So please do it.